Hey everybody, it's Mr. Bennett. We are back with a third set of notes. We have just about finished up with speed. We've done 2 labs on this. We've looked at a lot of problems. And I wanted to give you a set of notes just to round out the ideas so everything's kind of in one place. Remember that speed describes the distance traveled in a given amount of time. So that distance can be any distance, centimeters, meters, kilometers, whatever. The time can be any amount of time, so minutes, seconds, hours, days, doesn't matter. It's just a distance and a time. And there's 2 kinds of speed, well, two ways we can describe speed. A single point in time is called the instantaneous speed. Instantaneous. So that is a one snapshot, one individual measurement of speed at that point. Over time, we can take those measurements over and over and over, and we get what's called an average speed. And this is what you are used to dealing with. So when we're measuring speed in the lab, we're looking at an average speed because we're not taking individual times, we're not taking instantaneous times, but we're saying in general, this is how fast this object is going. Remember, speed is distance over time, d over t. You can also rearrange these to say that distance, d, is equal to speed times time. And we've got an example of that. You can also do time is equal to distance divided by speed. So we can rearrange this algebraically. We're using the algebra skills to find any one of the 3 variables. Always include units in your calculations. Always, always, always include units because it will help you keep track of what you're trying to do. So let's take a look at these examples. We're on a road trip with some friends. We are not paying attention to the driver, but we notice we've gone about 80 kilometers. So here's a distance in 45 minutes. There's a time. Should you be worried? Well, to know that, we have to calculate our speed. So remember, speed is equal to distance divided by time. So we plug in our variables. So we have 80 kilometers, and our time is 45 minutes. And it's simple division. When you divide these two, this gives you 1.7. Now check out your units. Kilometers, right, and minutes are not exactly the same, so they do not cancel each other out. So 80 divided by 45 gives us 1.7, and this is kilometers per minute. I'm going to let you convert that to kilometers per hour, and I want you to tell me, should we be worried? So you can let me know either in class, or actually you can leave a comment if you want to. Example number 2, how far would you travel if you walk 3 meters per second for 15 minutes? Here we've got 2 units, meters and seconds, distance and time, so this is a speed in 15 minutes. The first thing we have to do here is we have minutes and seconds. I cannot compare those one to one, so we just need to convert 15 minutes into seconds. Remember, to do this, we assume this is over a 1 second. I'm sorry, not seconds there, it's just over a 1. And in our conversion factor, I want to cancel minutes, and 1 minute is equal to 60 seconds. So we do 15 times 60, which gives us 900 seconds. Now I can take this. The question is how far, so if we look back at our equations, I'm using my distance is the speed times the time. So we're going to do 3 meters per second times, not equals, times our seconds. 900 seconds equals, seconds cancel out because we have 1 on top, 1 on bottom. 3 times 900 is 2700 meters. This is the only unit left over in your equation, and so that carries over to your final answer. We have a distance, so make sure your answer makes sense. Finally, how long? How long? So time, should it take a bowling ball rolling at a speed of 10 meters per second to travel 48 meters? So we're going to look back up. Time is distance divided by speed. So when we fill out our equation, remember t is equal to d over s. So we can set this distance at 48 meters over 10 meters per second. Meters on top, meters on bottom, these are going to cancel each other out and leave us with seconds as our final unit. And when you divide this, you end up with 4.8 seconds. Make sure your time is the only thing left over. This is why units are so important. So that's how you use it. The big things, make sure you understand what these are doing algebraically, how we're using them, how to get from one to the other. And there's two critical thinking questions. You can take a look at these. One of them has to do with speed, instantaneous or average speed. Think about that. And another calculation, thinking about how does speed change over time? How does speed change? As always, you can ask me in class, or you can leave it in the comment. If you want to leave your answers in the comment, I'd be happy to reply to you there as well. Thanks for listening, and I'll see you in class.